This is the third installment of adding and subtracting rational expressions. This particular video is going to deal with binomials or trinomials in the denominator that are like. So my denominators are going to be like, but I'm not going to have monomials. Okay? So a couple things you need to remember. Again, monomials make it a little easier to do multiplying and finding denominators that are the same and so on. When we have binomials or trinomials and we want same denominators, we can look at them and see if they're the same. The 2n plus 6 and the 2n plus 6, again, we can look at them and say that they're the same. But in order to make my life easier down the road, I want to go through a different way of how to do this. Okay, other than just adding my numerator up top and bottom and so on, this is going to make it easier when we get into unlike denominators. So here's what we're going to do. When I have binomials or higher, meaning if you have a binomial, a trinomial, any kind of polynomial in the denominator. So any kind of nomial in the denominator, I'm going to abbreviate denominator as denom. Okay, factor first everything. Okay, so factor first and then factor everything. So if I look at my denominator, we know that they're the same because visually they're the same. But factoring, what does that look like? Well, these here, the 2n plus 6, they both contain a 2. So that's really 2 times n plus 3. And then 2n plus 6 over here is really 2 times n plus 3. Okay? So that's going to help me later on down the road. Because when I need to find common denominators, that's going to be easier to do. So, but because my denominators are the same, it's 2 times n plus 3 is my denominator. My numerator is 2n plus 3, and then remember this plus gets distributed, plus n plus 6. So if I add like terms in the numerator, I get 3n plus 9 over 2 times n plus 3. Well, I'm not done. Some of you might be like, well, we're good to go. We're not. This 3n plus 9 can be simplified, factored even more. What I mean by that is they both contain a 3. 3 times n plus 3 is 3n plus 9 over the 2 times the n plus 3. Well, now if I look, oh man, it makes it so much easier. These are both binomials, and guess what? They're the exact same binomial. Remember, I can only cancel out binomials and binomials, trinomials with trinomials, monomials with monomials. But they need to be the exact same when we get to binomials and trinomials and so on. Monomials, they don't have to be the same. You can just reduce them from there because you can divide them and make them smaller. So I have 3 over 2. That's the only thing that I have left. Let's look at this particular problem. So I have r squared minus 3r minus 4 in both denominators. Yay, they're both the same. But remember I said I want to factor. Factor, factor, factor. Okay, so here's what's going to happen. Remember, I make an x. My negative 4 goes up top. My negative 3 in the bottom. So my side numbers are going to be negative 4 and positive 1. Remember that I'm putting them in parentheses. So I divide the negative 4 by 1 because that's what my a value is. Because they both reduce to numbers, negative 4 and positive 1, they both reduce to integers, I can put the negative 4 there, the positive 1 there, and then r here and r there. So I get r minus 4 and r plus 1. That is what your denominator, your trinomial, factors into. So now my answer is going to be r minus 4 and r plus 1 in the denominator. Maybe I can cancel later, I don't know, but right now that's what we have. My numerator is 2r minus 4, and then this negative here distributes to that binomial. So it's minus r minus 6. So now let's simplify in our numerator. 2r minus r is 1r, or just r, but 1r is fine. Minus 10 over r minus 4, r plus 1. I'm going to get rid of the 1 in the numerator there next to the r. Now, if I look, I have a binomial up top, and I have two binomials in the denominator. Are any of those binomials the same? Meaning they have everything the same. Yes, they contain r's, but do any of them contain a negative 10 other than the one up top? No, they do not. So this is my final answer. Go ahead and pause the video for this particular problem. See if you can do it. If you have an answer, then hit play. If you don't have an answer, again, still hit play to make sure you know how to do it. So if I look at my denominators, again, I can tell that they're both the same. But factor. What do they have in common? Well, they both contain a 4, and they both have v squared in them. What is left? V plus 2. This binomial factored to a monomial and a binomial. Okay? If I distribute, I get what I started with. That is the goal. So my denominator here is going to be 4v squared times v plus 2. My numerator is v plus 4 and then plus the 3. So now combine terms up top, v plus 7 over 4v squared times v plus 2. Well, here I have a monomial, binomial, binomial. Are any of them the same? Yes, I have two binomials. Are the binomials exactly the same? No. One has a 7, one has a 2. They are different. So answer is v plus 7 over 4v squared times v plus 2. That's your final answer. Go ahead and pause the video and try to do this one. Again, hit play to make sure you're right, or if you don't know what you're doing, again, to make sure you kind of follow along afterwards. So if I look, my denominators are the same as well, but factor first. What do they have in common? They both contain a 9, and what do I have left? X minus 3. So that we know is our denominator in our answer to start with. Up top, if I look, I have the 4x minus 6, and then this is a minus 6. So I get 4x minus 12 over 9 times x minus 3. Some of you might think you're done, but we're not. This numerator is a binomial, but can be simplified or factored even further. I can take out a 4. What am I left with? I'm left with an x minus 3. 4 times x is 4x. 4 times negative 3 is negative 12. I get what I started with. That is the goal. Over 9 times x minus 3. Oh man, we got some awesome stuff. You guys can tell I'm so excited. That's a binomial. That's a binomial. They are gone. They're the exact same things. What do I have left? I just have 4/9. That is my final answer. This concludes adding, subtracting rational expressions with like denominators, where their denominators are either binomials or trinomials. If you need help with binomials and trinomials in a denominator with unlike denominators, please watch the next video.